Hey, I bet you've been curious about this thing called utility scale batteries and the evolution of both utility scale solar plus storage and batteries as a standalone product. You're trying to get your business head wrapped around how to integrate it into your own product offering. Boy, have I got a book for you. This is a Tactical Tuesday to be Tactical Tuesdays here on Suncast. If you are new here, welcome in. Can't thank you enough for giving us the only non-renewable resource you got. That, of course, is your time. And if you have even the slightest amount of curiosity about batteries, today we will satiate that palate, that desire. And perhaps you are looking at transferring your skills from some other sector, or like many of our friends, transfer from solar to batteries. Well, never fear. If you felt unprepared, I have the answer. It is called the BESS Book. I very rarely do this, but I'm so excited about this product because I actually think that it is the book that the industry has been waiting for. And now I get to say of a friend, he's the guy that wrote the book. And I'll say they because Drew Lebowitz and his co-authors, Swetha Sundaram and Sean Daly, are the geniuses behind a book that, frankly, is too long in the coming. A cell-to-grid guide to utility-scale battery energy storage systems. Drew, Swetha, and Sean are industry OGs like myself and many of you. Today, we're going to dive deep into how and why this book came into existence, why I think it should be required reading for everyone in the industry. It should be on the shelves of every book, every every bookshelf of every EPC, every book club. It should be promoted by SIA. No kidding. Like, even though I'm not getting paid, by the way, to promote this, I just genuinely think that this is a product too long in the coming, and the industry has been waiting for it, which is why there's been such great reception. We'll talk about that and more. If you are not yet subscribed to the Suncast podcast, I don't know why that would be. Maybe it's because you're watching us on YouTube and you haven't subscribed to that channel either. Give you an opportunity to do that right now. I'll wait. Sweet. That's about as long as it takes. So thanks for subscribing. You are now going to get this kind of content in your inbox twice a week, every week. Leaders on the front lines of the clean energy transition, doing what it takes to evolve our grid to renewable power and off of fossil fuels. Get ready for another tactical, practical tune-up on your skills, Solar Warrior, as we dive into another fantastic episode here on Suncast. Well, it's, as I said, long in the making. My friend Drew Lebowitz and his co-authors, Sean Daly and Swetha Sundaram, have created this fantastic book called the BESS Book. And I want to welcome Swetha and Drew to Suncast. Thanks for joining us.
Thanks,
Thanks,
Nico.
Nico. It's great to be here.
In fact, it is great for me to have you here. I'll give the folks a little bit of a quick intro. If you're unfamiliar, Drew has been in the solar industry for quite some time. He and I are both also returned Peace Corps volunteers, pulling the heartstrings of some of you folk out there. He's the principal managing director at PowerSwitch, which is an advisory firm based in Portland, but he also has worked for some heavy hitters like DNV on exactly this topic. So we'll find out a little bit more about how he and Swetha came up with the idea for the book. But this Cornell grad has quite a bit of time focused on energy access and renewable energy. Swetha herself pulls her own weight. She's for sure not riding on the coattails of Sean and Drew. Swetha has been in the industry for quite some time, now working at RWE as the Director of Energy Storage Project Design, helping renewables developers figure stuff out. I think that one of the most surprising things that I've heard from Swetha is the sheer volume of standalone BESS projects that they're working on. And of course, prior to that, she worked with Drew and Sean at DNV. Folks, I could regale you with just how smart these folks are, but I'll let them do it themselves. Drew, why don't we start with a quick roundup of how you, Swetha, and Sean decided that this book needed to be written at all?
Absolutely. So when I joined DNV back in 2019, I had the great fortune of working on their energy storage engineering team, which at the time was known as the DER team, really prior to storage really taking off. And so I was there on the ground floor. At the time, a big project was around 10 megawatts, maybe 20 megawatts. Now we're seeing projects that are 700 or 800 megawatts. So
Yeah.
it's really taken off. But at the time, I was diving into independent engineering, owner's engineering of battery projects as they were getting bigger and bigger, as the interest in the industry and the financing for those projects was rising very quickly. And I realized that I had a lot to learn of getting spun up on those types of projects. I had worked in mostly C&I batteries in the past. So getting spun up on utility scale, I was looking for a guide, looking for something I could read. We found that there was a lot of information on the very technical side, down especially into cell chemistry and sort of the
Mhm.
PhD level aspects there. There were some that were more geared toward residential batteries and install of those products that were coming online, but really there wasn't anything that covered the breadth of the industry. So had the idea back in 2020 to start putting this book together. And I started kind of coming up with a topic list, looking at what was needed by the industry, who was going to be the audience. Ended up coming up with a concept and little by little working on it. We later brought in first Sean Daly. Sean at the time was working at the wind side of DNV, so he brought a great perspective of shifting from another part of renewables. Later brought on Swetha, who at the time was also on the energy storage engineering team. And little by little, we chipped away at it, put these chapters together, finally made a big push this year to launch the book. And we were really glad with what came out the other side.
Shweta, you and your co-authors had a big coming out party in late June, early July, as I recall, coinciding with the ACP forum in Portland. How I'm eager to know, how was that well received? I anticipate that there is just this pent up demand for a book like this.
Yeah, absolutely. I think we timed the launch party with the ACP Recharge conference, which is ACP's inaugural energy storage focused conference. So given that it was an ACP event, it was very well attended. And we had done a good bit of marketing on LinkedIn. So I think there was a good buzz around, with a lot of people interested to know more about the book. And there was very good attendance at the launch party. It was very surreal to actually sign a book and, give those out. I never really thought I could do that, in life. So it's been a fun journey. Absolutely echoing Drew's thoughts. So I was also, on the same team as Drew at DNV. I was more focused on the independent engineering side of things. What that means is when the projects are, at their late stage of getting constructed and they're talking to financiers for financing, that's when the financiers look at an independent agency like DNV to do due diligence on all things technical risks, financial risks, supply chain risks, all those things, right? So we had a really good front seat to all these kind of overarching problems, and we had a good bird's eye view of so many projects. It's a great space to be in consulting because you get to see different developers, different contracts, different projects, and the different challenges. So I think that gave us a very good breadth across all these topics. So we've really tried to put all those insights into the book, as well as me, going back to the developer space. And I have even more of a front seat to all the challenges we face, right from development phases to execution and operations. So really try to channel all those perspectives and make it as practical and useful as possible for a wide range of audience.
And I mentioned you have a third co-author, Sean Daly. Drew, put into context for us who the book is for, because I think a lot of folks maybe I'm gonna say the book is for folks that are both getting into the industry and folks that are deep in the weeds in the industry for different reasons. Contextualize who the book is for and how the three of you divided and conquered this really large task of trying to make this book accessible and inclusive.
I first wanted to say, unfortunately, Sean could not join us today, but he is a great example of, as I mentioned, someone who came from the wind side and said, I see storage as the future. I see it growing really fast. I want to go from climbing turbines to working on these massive utility scale projects. And he did just that. He is now at Acacia Energy, who is developing the most powerful battery in the world. It's an 850 megawatt project in Australia. And so he is sort of walking the walk of actually making that transition.
What a cool work transition story as well.
Yeah, he's done really great, and Acacia is really taking off. By the way, that's one of the case studies in the book. We have 3 case studies where we look at in depth at 3 different projects, and Acacia was generous to share some of that info about the project.
And the book itself is structured in a way that, I mean, I kind of look at it almost as an academic book, but how do you, I'm sure you get asked this, like, who's it for? Who's the intended audience?
Sure. So when we first started thinking about the concept, we thought about there's just such a wide variety of people that are involved in the industry. I'd say at the core are developers, people like Swetha and Sean now, who are out there looking at, where do I want to build my battery projects? How are they going to make the money? Where can I get the financing for them? How do I actually build them and then eventually operate them or sell them? So I'd say developers are the core of our market. I'd say, and that includes both new folks that are coming to work for developers, whether they're joining the industry early in their careers or whether they're moving from wind or solar into storage, but as well as people that have been in the storage industry. The content is designed in a way that it is simplified enough that the newcomer can understand the concepts, but it really goes into some depth on a lot of topics that I think even professionals that are in the industry really find interesting. So that's the core is developers. We also have a good part of it focused on the finance community. There's just a lot of people that are, especially with the IRA provisions, everyone in that community between equity, debt, and all the other players. We have a good section on EPC. So how do you actually build these projects? Everything from the project managers or construction folks that are working on them down to the electricians and people that are out in the field doing this work. And then lastly, even anyone from consultants, researchers, others on the periphery of the industry, really there's something in there for everyone.
I want to point out for folks that aren't holding the book in their hand yet, not only will we link to how you can get it, but fully 116 pages right in the juicy middle dedicated to project finance and EPC, what we call engineering, procurement, and construction, which means that much is history of the industry, and that much is how you can play a part in it. I love to be able to use it as a visual aid. Thanks for sending me the book, by the way. Thank you also for signed copy. I think that will be valuable someday. But I want to kind of reverse engineer the way the book is laid out. I noticed that workforce development, a buzzword right now in the industry, is the last chapter in the book, not the first. It's not, hey, if you're looking to get a job in storage, it's the last chapter. Talk to me about what you discovered in the process of writing the book about the need for help getting into the industry and why you included a chapter on workforce development in what is essentially a technical book on batteries.
When we first looked at the content, we realized that just understanding what was happening deep in these batteries was number one. We wanted to cover the tech from the ground up. So we start with cell chemistries, on the molecular level, what is happening. We don't go too deep into that, but we want the reader to kind of understand here's the different flavors of battery within the industry. We do focus on lithium-ion. That was a decision we made early on. We know there's a lot of other tech out there for storage. There's a lot happening in long duration storage, but we decided from a commercial focus that was really going to be the heart of the book because it is the largest volume of projects that are happening right now. And we decided to build up from there. So we start with cell, we move to module, to rack, to system, the system encompassing everything else, not just within the container that has the battery, but also on your project site, everything from interconnection to the civil work to how you are actually laying out these systems and controlling them and building them. Then we move on to the construction aspect, how do they get built, the operations and maintenance aspect. So we decided to walk through kind of this full life cycle, including the finance in there as well. And then we said, once you've understood kind of the A to Z of storage, where do you want to get involved in that industry? Because we knew some of the people that are reading already are in the industry, so they, may say, okay, I know everything there is to know about tax credits, but I don't know that much about the different products that are in the marketplace. Or conversely, maybe I've built 10 gigawatt hours of projects, but I don't understand everything about the O&M of how they actually get operated in the field. So the last piece we divided into 3 sections, which was first, I am a new career entrant. I just graduated, say, from undergrad or grad school. I want to get into this industry. How do I do that? And walk through a few of the avenues. To be clear, it's not just university folks. We have a piece that is focused on electricians and people that are hands-on getting into the industry, all the way up to the people that are in finance, throwing around hundreds of millions of dollars. So all these different avenues of getting into the industry. Then we said, okay, I'm in wind or solar. So for example, Sean, who was in the wind side, I want to move to storage because I see that being an avenue for growth. And to be clear, it doesn't have to be, I'm 100% switching. A lot of developers like RWE are still doing a lot of other renewable projects. They're just also doing storage. So that was the second piece. And the third was saying, I'm in a totally different field. I am a mechanic and I want to get into storage or whatever that field might be. And try to talk about those three avenues. And of course, it's a different path for each, and it'll be a different path for each individual. But trying to give at least an outline of the diversity of the field, because I really think it is a field where you cover so many different segments, and it has a lot of room for growth. Currently, I think we're, at least in the US, I think it's around 70,000 jobs right now directly related to energy storage. But that is growing very quickly. And of course, it's growing worldwide as well.
Yeah, and maybe just to add to that, we did want that to be one of the takeaways from the book. I guess that's also part of why it's towards the end, and just lay out the landscape and see what part you like and ways to get involved. And even within like a classic developer shop like RWE, we have all these functional teams, which I suspect to be the case with most, at least large developers, right? So there's a development focused team, there's a commercial team that looks at market analysis, there's, procurement team. And we often see that, they don't know much about the technology, or we don't know enough about the financing. And, there's so much of inter-exchange that goes on. So that in itself, I think, is a great reason for this book, because even if you are in the storage industry, there's always things that you don't know. And there's gaps you could get filled in on. Like my team is already asking me about, okay, are you covering this, are you covering this? So yeah, so it's definitely, that's why we intentionally made it comprehensive, so that it tries to target like a wide range of people.
Was there anything in terms of feedback, early reviewers, that helped you amplify the different ways to think about workforce development? I do feel like there's been a lot of renewables to storage. For me, I mean, we've been in this industry collectively now for more than a decade each. And I see a lot of my friends, the light bulb went off maybe 2, 3, 4 years ago. Oh my goodness, battery storage is taking off. I guess the question I have is, through the process, did you uncover any specific transferable skills, things that people maybe are overlooking, that make it a logical transition, or underlying skills that fit the storage sector specifically, that maybe are non-obvious?
That was also a point, I think, that kind of becomes evident in the book, is there are a lot of similarities in like the functional aspects of building a BESS project. That's very, very similar to PV, right? Like, for example, starting with a developer, again, at RWE, we are already seeing the development teams kind of get shuffled across technologies. And there's a lot of transferable skills in terms of what you need for developing a good project, to identify the business case, to understand the permitting requirements. Of course, there are nuances for storage that are very unique, and there are things to learn. But the baseline skills apply. And from an engineering standpoint, these are electrical systems, again, very, very different in like physical form and, the use case and all of that. But there are some baseline engineering, diligence that we do to make sure, like, for example, the container is compatible with the inverter from a voltage standpoint, current standpoint. Those kind of things are definitely transferable from the PV world or even the wind side once you have the interest. And same for like procurement, you're kind of looking at the same type of risks as you would in the PV space or the wind space. Is there supplier diversity? Are we covering performance guarantees, in the same way as PV or wind? Supply chain, are we kind of covering our bases there? So definitely lots of transferable skills. It's just about understanding the nuances of energy storage as a system, and its use, its application, that needs to kind of bridge that gap.
I think that one of the things that stands out for me over the last 5 years of coaching folks on transferable skills, in particular, trying to get a job in the industry, is two often overlooked areas that lead to excellent transferable skills from any industry is buying, basically procurement, buying product, no matter what field you're in. If you're a buyer for Walmart, all the better, right? If you're a buyer for a big company, no matter what, procurement in the solar industry or the battery industry, especially to the extent that you need to go downstream or upstream and really evaluate the raw materials and the supply chain. Huge demand in that skill set. The other is project management. I had someone on recently that basically said, you want to have a fast track to have entrepreneurial skill, eventually build an entrepreneurial or build your own company type of venture, learn project management and go to work for big companies like RWE or Worley Parsons, right? Go work for some of these big companies with that project management skill, and it prepares you really well. So I think those are two overlooked skills. Drew, anything that revealed itself to you in the process of writing the book that is applicable for folks that are in that career transition?
One of the biggest things that I think differentiates batteries from wind and solar is the controls piece. So you obviously have energy flowing in both directions, which is different. But because of that, it opens up a lot of services that batteries can provide. Batteries do not create energy, unlike wind and solar. In fact, they use up energy. You always have some losses in there. So the way that they're making their revenues is that they're providing all these different services. It might be frequency regulation. It might be arbitrage, buying low and selling high. It might be providing critical services on a very hot day, being ready to discharge on the grid. And you can be doing many of these at the same time. It's what we call revenue stacking. And so the controls piece of figuring out which should I be doing at any given point in time is quite complex and involves everything from, every cell in the system, and big systems can have over 1 million cells, every few seconds can be measuring voltage, current, and temperature. So you end up having these gigabytes of data that are coming off these systems, and processing that data, optimizing it, figuring out what decisions I should make, both in the marketplace and for operational aspects of the system. That's a huge part of batteries. And we actually devote a whole chapter to it. Chapter 5 is all about battery controls, from the cell level all the way up to the system or even fleet level controls. And I think especially today with the growth of AI and the kind of rise of data science as a huge skill set, that is one I strongly encourage everyone in the industry to take very seriously. And there is a big role for people that are working in data to play in the storage industry.
Yeah, as you were saying about the transferable skills, I guess I want to emphasize that the BESS industry actually needs those skills from, people experienced on the PV and the wind side, like, for example, navigating supply chain challenges, managing project execution, and even operations, right? Because the BESS industry is at its infancy in this aspect of like really facing these issues. And as projects are getting built and we're suddenly having the swell in supply chain bottlenecks, for example, tariffs, understanding the political climate, how to prepare for that. So, I think we could definitely benefit from, people kind of bringing that expertise over from the PV and wind side.
One of the things that as I described to you guys, when I got a copy of the book to review, I start from the back, and I didn't actually spend any time in the beginning. So I'm unaware of whether or not you cover the premise in the beginning, but one of the things that stands out to me is the book is entirely focused on lithium-ion. And there are numerous different storage chemistries and technologies, from flywheel to flow batteries to, dammed water. So hydropower. How and why did you land on exclusively focusing on lithium-ion as a technology? Kind of walk me through, if you will, a little bit of the options that you looked at, the favored versus fading conversation, and kind of how you think about focusing entirely on this chemistry.
So energy storage is a really broad field, as you mentioned, Nico, and includes those hydropower dams all the way to new vanadium flow batteries to iron air and all these different chemistries. I think the first thing was we knew even just within lithium ion, it's a huge amount of content, and so we wanted to make sure the book wasn't getting too fat and covering too many topics. Otherwise, we never would have finished writing it. So that was one part of it. Secondly, I wanted to mention that lithium ion, just from a terms of a megawatt or a megawatt hour basis, has really outpaced all those other technologies, including, by the way, pumped storage, which actually just in the past few months, lithium ion overtook pumped storage, which many people thought would never happen. And so, just in terms of a commercial basis, if we were to look at megawatt hours or even easier dollars that are flowing to finance these projects, lithium has taken off and sort of gone to the moon. That said, I don't think lithium will be king forever. There's already a number of technologies that are sort of coming for it. For example, sodium ion is being touted as a new tech that may be coming for the crown. And we do cover in chapter 11 is the future of energy storage. That includes these things like different types of chemistry, but as well as things like V2G, which is vehicle to grid. How do we take the lithium-ion batteries that are zipping around the streets in EVs and use those together when they're connected to the power grid as a single unit? And many people think that may come to dwarf the stationary storage, which are these projects that we're working on. So we do cover the topic, but really for terms of brevity and making sure it was focused on where the investment was, we settled on lithium ion.
When we all started looking at battery energy storage, by and large, it was as an extension of PV, solar photovoltaic projects, right? It was this idea of solar plus, PV coupled projects. Swetha, you said something to me before we started recording that really took me by surprise, that fully half of the projects our WE engineering teams are looking at are now standalone battery energy storage. Could you talk about the rise of standalone, the historic nature of kind of DC and AC coupled projects, and what is it that in the marketplace that is finally supporting the idea that a battery energy storage project itself is a power plant?
Absolutely. I definitely remember the times when storage was, that third child and lost child very often. So very, very glad to see the turn of events and how quickly that's happened, where storage is definitely, taking a very big share of, I'm sure, most developers' pipeline of projects in terms of megawatts and megawatt hours. So yeah, the PV plus storage premise is definitely still relevant. It began thanks to the investment tax credit that solar primarily was riding on, and then batteries were basically riding on that because when that was rolled out, there was no standalone storage. There was no credit for standalone storage. So to make the economics of a battery plant work out, it was a condition that it has to be co-located with a renewable resource. For the longest time, it's made sense to do that with PV. So that was the primary reason for storage always being PV paired, because as per the old ITC rules, you had to show that the BESS needs to charge from a renewable source at least 75% of the time. And of course, it has synergies of having common costs of development, of construction, lots of synergies there. So it definitely still makes sense, and it's a large part of the portfolio of projects we're looking at. And also, balancing PV's intermittency. It can be used for a wide range of use cases, as we know, but for making the product more firm as an output. So it's an integral part of PV's growth, and that's not going to change. But thanks to the IRA, it has really opened the floodgates for BESS as by itself, for standalone BESS. And what we're seeing increasingly is the opportunity to develop BESS in more urban areas where there tends to be more congestion and more opportunities for energy arbitrage, price spikes, and really making use of that, the congestion and the basis opportunity there. So that's been a key shift. Also for ancillary services, right? Like it's creating the use case for having these BESS systems out there, especially as we're seeing in ERCOT. There are tons and tons of standalone BESS projects coming online in ERCOT. and in California as well, where storage is being accepted as a capacity resource, right? So from a real estate land availability standpoint, it frees up a lot of constraints that otherwise we had when it had to be paired with the PV. Now, answering the question around DC versus AC coupling, yes, again, in the realm of the ITC, DC coupled projects looked very favorable because they were able to capture clipping losses from the PV, and it made, again, a natural justification that the battery is charging from the PV, more than 75% of the time. So that has seen a demise, if I may, in the industry, simply because it's too hard or extra complicated to design, to construct, because you're basically having these BESS containers spread all through the area of the PV field, which otherwise you use like a fraction of the space, and everything is in a concentrated space. So just from like an execution standpoint, as well as an operations and maintenance standpoint, it tends to be complicated, as Drew was alluding to, from a control standpoint. So it just seems like it's added complication for not as much value. So AC coupled systems are definitely, I think, here to stay. The BESS is almost like its own plant from, again, a design and construction standpoint, really much simpler to execute and maintain. It's also easy from a permitting standpoint to kind of keep them as decoupled, so to speak, as possible, but using the same physical space. So this seems to be the trend, and that's what we're seeing internally as well.
One of the things that I contemplate often in these interviews is like, how deep do I go down a rabbit hole? And I thought, gosh, I'd love to have them explain AC versus DC coupled, but I won't, because they do such a good job in Chapter 8, including these fantastic graphics.
That's right.
I've never seen anybody actually draw it out. I've done actually like 5 or 6 different interviews with battery manufacturers who want to talk about the value of AC versus DC coupled. If you guys are really curious, we'll link to those in the show notes. But I would encourage you, when you get your copy of the BESS book, turn immediately to Chapter 8, read it in its entirety. If you want the answer to AC versus DC coupled, it's right there on page 266, including revenue examples, i.e. why and how you make money using one architecture versus the other. I mean, it really, this book, especially certainly for the utility scale minded developers, is a masterclass in many different ways. I mean, all the way down to, and I love the way you guys even incorporated things in that chapter, like commercial terms. How should you think about the commercial terms of buying this product? Drew, it must be challenging then to think a little bit more as the industry as a whole. Obviously, I don't know that you had the time and breadth. It would have been instead of a 500-page book, it would have been a 1,000-page book to include residential. But commercial projects do sort of start looking like these utility and grid scale projects. How did you think about and incorporate the C&I, commercial industrial sector, into the book? And are there good examples that you could draw from?
When we were first defining what ground we would cover, we thought a lot about this because, as you mentioned, C&I projects are getting more prevalent. The costs are coming down for C&I and resi battery products the same way they're coming down for utility scale. And at their heart, the cells and the chemical reactions that are happening in those systems are totally identical. So I think a lot of the book, especially the earlier chapters, really just apply across the board. We did, just to keep it focused, decided to center in on that utility scale aspect. However, there are a number of places in the book that do touch on C&I. First of all, one of the 3 case studies is of a microgrid that is battery powered up in Seattle. It was funded by the state of Washington, and really does a good job diving into the ways it can use the solar to become a microgrid if there was a grid-wide outage, how they can reduce their energy bills by cutting demand charges. So a lot of that case study applies. And then also when we talk about the future of energy storage, there's quite a bit on VPPs, or virtual power plants. And that section it really is focused on combining smaller systems, whether they're residential,
Mhm.
whether they're CNI, to operate as if it was a big utility scale project. We've seen a lot of advancements in that field, both on the physical plants themselves and the controls that cover that. And so, between those two areas, there are aspects that apply to CNI, but we did make the decision really to keep it from exceeding 1,000 pages to focus on utility scale.
That example of the Miller microgrid that you use as the case study for CNI surprised me in a few ways reading through the case study. I think the number one is that I think people assume that CNI largely is done by local contractors rather than major multinationals. Was surprised to see that it was a Worley Parsons job, frankly. What do you feel like people, upon reading the section on CNI, microgrids, and even the case study, are going to come away with? What was the biggest surprise or takeaway for you? Are there notable differences in approach or equipment, et cetera, that do differentiate CNI from utility scale?
So we have a section on use cases that occurs early in the book that says kind of, here are all the different things that can be done with storage. And so for utility scale projects, most of that is focused on money. How am I participating in markets that make me the money? How do I get those contractual relationships that are going to pay me X amount per year? But another big use of storage, and one actually that I think most people that don't know the industry well, that's the first that they think of, is resiliency. I have a Powerwall or whatever product in my garage that when the power goes out, it could power part or all of my home. And so this case study was focused on highlighting that, yes, the utility scale revenue streams are powering those huge projects, but resiliency is also very important. And a project like this, it can be sometimes worth quite a bit, even if it's not directly from revenues of the project. Someone being able to, in a power outage that might last 3 or 4 days, going to charge your phone at the library, or being able to have that as a gathering point, that's worth a lot. And I would highlight too that just because it's off grid doesn't necessarily mean that it's a small system. This one is on grid, but it can island and become off grid in the case study. But we see some applications like mining, for example, where there's a 50 megawatt PV coupled with a 30 megawatt battery. Those are big systems and they're totally off grid.
Right.
And so, those applications, I think, are growing in popularity just as the grid tied utility scale projects are.
Great example. I was actually surprised at the relatively small size of the solar, which I have to imagine is constrained by the rooftop and sort of available space for this facility. But that's one of those things, like, not uncommon to see more PV than storage, but in most of the microgrid scenarios, we see more storage than PV. And I often liken it to civic infrastructure, right? Like, this is something that municipalities, fire departments, et cetera, in emergency scenarios want to be able to rely on. And we see that even more prevalent in the Caribbean as we, at the time of this recording, like, unprecedented Cat 5 hurricane barreling through the Caribbean. Puerto Rico, if they are to be affected by any of these, what is certain to be the worst hurricane season on record, have a number of these centers that are civic infrastructure that have been invested in by the local government to create these islanded microgrids in the scenario that the rest of the community is offline. And just story after story of how impactful it has been in the island communities, and how those use cases, both in Puerto Rico and Hawaii, can be extrapolated to municipalities across the United States and indeed around the world.
To build on that quickly, Nico,
go for it.
As we mentioned, tax credits are a big driver of projects in the U.S., and now Canada has a similar ITC. But I did want to point out that the book does have a global focus, that we are kind of looking at markets all over the world. We have different sections of the book that talk about the different market drivers. There are places like Australia, Chile, South Korea, China, where they don't have a tax credit system the way we do in the US, but they're still building massive projects. They're finding use cases that are unique to those markets. And so I wanted to point out that it applies to the US, and we have US focus just being here. but also there's aspects that are totally global. And we've seen a really positive response from these markets. I've gotten some great contacts through LinkedIn and other channels from India, for example, or even Europe, where there hasn't been as much development. They're sort of catching up a little bit, saying, what did you do in those markets? How are you building so many systems, so many megawatt hours, and how do we replicate that?
While we know and acknowledge that there is a general fervor for battery energy storage and to complement renewables generally, both wind, solar, and other types of renewables, so that we have firm power, so we have 24/7 reliable renewable energy. There's not an there's perhaps an unhealthy. There's not an unmeasurable amount of backlash and concern. Are these assets safe? Are they being used to extract resources from places like the Congo that we will pay dearly for down the road? What about fire concerns, et cetera? I noticed that there's an entire section dedicated to environmental and safety concerns, chapter 10, which also includes probably my least favorite topic, codes and standards, not because I don't appreciate them, but because it's just like baffling how folks like you all and our friend Ryan Mayfield can kind of hold it all in their head. Swetha, I know that this is a particular area of focus as an engineering firm and an engineer yourself that you all have to pay close attention to. What would you highlight about the safety environmental concerns chapter, in particular, the codes and standards and interpretations as it relates to battery energy storage?
I think the industry has come a really long way in developing these codes and standards, and thank God for them for finally being accepted pretty widely. I'm talking from OEMs that are at this point heavily based out of the US, outside the US, but they're also definitely very familiar with these codes and standards that are required in the US. And also these local authorities that are spread across the country, right, as we develop projects all across the different states. So it's really very helpful to have a uniform set of codes and standards to say, okay, if my product is NFPA 855 certified, for example, you're checking a lot of the boxes that would otherwise be like an individual discussion with the permitting authorities and with the OEM, and it avoids a lot of back and forth. So definitely it's great to see these codes and standards being established and normalized. I think the industry is at a point where most of these containerized systems are meeting these codes and standards like NFPA 855, which is an umbrella standard, and it kind of dips into many other standards like NFPA 68, 69, 72, which we explain. We give a broad overview of these codes and standards in the book, which also I think I personally really, I wouldn't say enjoyed, but I felt like, okay, this is going to be of value because I know it can be very challenging to kind of pick through those and read the individual standards and really understand how they kind of come together. So we try to make it accessible for anyone to just have an understanding of what these mean and what do you need to meet as a baseline best practice to make sure your project is compliant with the different codes in place, fire codes. And it also really helps from a permitting standpoint and talking to the local authorities. One thing I cannot emphasize enough is please reach out to the local authorities that you're working with at your project sites early enough so that you understand where they are with their knowledge of energy storage, which is very varied, right? Like we're still building in a lot of rural areas, which are reliant on volunteer fire departments, for example. And obviously, they need to be brought up to speed with the level of safety measures that are being instated in these products. So that is a big takeaway that I would say is from that chapter. It's very important to get your community, the local stakeholders, the AHJs, everyone up to comfort on what you're building and why it is safe. One thing we like to kind of highlight to the local authorities when we're kind of starting from scratch on the process is how many layers of safety are actually there in these BESS systems as compared to like an EV or, a lot of other appliances that have batteries in them. You could argue that containerized BESS systems are much more safe
Right.
Of course, the catch being that they're huge and they contain a huge amount of energy.
Right.
But yeah, according to recent report released by EPRI, the number of safety incidents has come down dramatically, I believe as much as by 97% in the last 6-7 years. So the industry has really, really come a long way. It's one of the most emphasized on points from a developer standpoint, as well as the OEMs. Definitely a lot of emphasis in making the product safe.
It's easy for folks to see the three of you as listed as the authors on the front of the book, and to wonder, like, does this really hit everything that the industry feels is relevant? I think one of the things I'd like to point out, and would love you to go into detail on, Drew, is the fact that in a very academic way, this book was peer reviewed the way it might be if it were going to be presented as a peer paper for Scientific American or something similar to that.
So what we did was we took the main content chapters of the book, of which there were kind of the 10 in the center, and we found an expert for each one of those to review that section. So we had, for example, someone from AES, Christian Sanchez, who looked through the EPC chapter, that huge chapter, and kind of went, step by step and said, you mentioned this, but you forgot to say this, or you said this, but I've seen this in the field. And it was amazing how much changed between when we sent those to the reviewers, when we got them back and incorporated the comments. But it was also a really great feeling to see, like, there's a lot of perspectives. Even us who have a lot of experience, we've only seen a sliver of the projects that are happening out there, and you really have to get that kind of differing perspective in the industry to make sure if you're going to write the book, you present things fairly. So we had someone from the finance community, from Wells Fargo, actually reviewed the finance chapter, and they're throwing around hundreds of millions of dollars, and really know the latest and greatest on tax equity financing, to kind of inform that chapter. We had Mike Kleinberg from DNV, who's the head of the energy storage engineering section, Mike Kleinberg is the head of the energy storage advisory section there at DNV, reviewed that section, really brought up the level of that content. So we were grateful to have all these different reviewers contribute, and it became a really industry-wide viewpoint that we're expressing in this book.
As we start to wrap up here, there's a couple of things that I think probably still in the mind of anybody who is watching or listening, and that is around the evolution of how the product itself is manufactured. One of the things that I found fascinating is that you have a section dedicated to where the product is being made and where it's being consumed. There is a great graphic on page 304, for example, of lithium-ion manufacturing, cell manufacturing particularly, by country, which is 2021. So I'm curious your thoughts on the evolution of the industry, even since 2021, with regards to where and how batteries are manufactured, who the key manufacturers are, and sort of what is next. There's an entire chapter on the future of energy storage. Let's round out with that discussion. I'm sure we'll find a couple of rabbit holes to dive down.
So first, when you say batteries are manufactured, we have to talk about the different pieces, right? Because this is a global industry, things come from different places. So at the core, we have cells, battery cells. Every utility scale or any battery system has cells at its heart. And cell manufacturing really has been dominated by China. They made some very strategic investments, industries that have grown up around this, and then have kind of led the way when it comes to getting those energy densities down, advancing the chemistries. That said, there are now a number of other places where cells are manufactured. With the IRA, the U.S. has pushed ahead with a number of different cell manufacturing facilities. Those take a long time to build, but they're just starting to come online now. And over the next few years, we'll see more and more of that. Also, the aspect of tariffs between many countries, but especially the U.S. and China, has driven that to a large extent by changing the prices depending on where you're consuming the product. So that's on the cell side. But on the integrator side, so integrators being those firms that buy these cells, modules, or racks of batteries and then put everything else in them, the control system, the enclosure, they may even incorporate the inverter into the energy storage container. Those firms, there had been a number of different players, both European and the US, led the way. So you had firms like Tesla early on, who was in that space. others like Fluence, Wärtsilä, who got involved. But one big trend in the industry that we've seen is that those same cell suppliers, led by the big suppliers such as CATL, BYD, EVE, REPT, all those firms have started to have products that come farther up the value chain. So whereas before they only manufactured cells, modules, or maybe racks that they sold to those integrators, they've become integrators themselves. And you can go out now and buy, for example, a CATL integrated battery product. And you can do that same for many other different cell suppliers. There are still a number of integrators, some of whom still buy those racks or cells from the cell suppliers wherever they may be. But we've seen that as a trend, and I think that will continue as the industry evolves.
And maybe just to add to that, I think it's really interesting how fluid the industry is right now. Is everyone wants a bigger, share of the pie, and the margins are getting tighter and tighter. So traditionally, we relied on these integrators like, Tesla, Fluence, to give like a complete package, right? Like beyond the DC, the batteries themselves in the container, who provides the PCS and the EMS, the energy management system, which is, as valuable, as the other components. But it is interesting to see that the downstream cell manufacturers are kind of growing into that space and daring to take on more of that scope because they can see that they can do it, and they might as well take that market share. So it's giving us a lot of options as the developer. So it's a good place to be in and really interesting. And another point is we're seeing a lot of announcements of AC blocks where the inverter is actually inside the battery container. Again, an interesting trend to watch out for and see if it actually, picks up momentum, because the battery containers are getting really dense. So you are saving a lot of footprint already, but it does, make things easier if the PCS is integrated in the same container. So another trend to watch out for. And finally, across the traditional swim lanes, if you will, so there's traditional PCS providers who are, coming into the battery space. There are even PV module manufacturers coming into the battery space. So it's definitely fierce competition out there.
Yeah, I found a lot of the PV module manufacturers, as they are prone to do, are doing some white labeling, but I was really surprised to speak with one recently. I won't name who it is to not play favorites, who is doing complete cell manufacturing.
That's right.
Themselves. Genuinely, I was floored when I spoke to the general manager who shared that startling news. A leading manufacturer, no less. So if I were in the battery storage market like Sungrow or Lithium or even CATL, I would be very concerned about the new entrants. It's kind of like it's just like PV modules a decade ago. It's like trackers today. It seems like at Intersolar, every other booth this year was a new tracker provider. Well, as we wrap up, I have a few kind of quick questions that I hope will give folks some parting answers to questions that are lingering. One was, as I reviewed the performance guarantee table, I was reminded there is still so much I don't really understand that I want to understand about batteries. And one of those is you've got a whole section on round trip efficiency in the BESS project chapter. Could you quickly define the importance of round trip efficiency and its sort of characteristic as a component of a battery storage project?
By definition, every battery cell, when you put energy into it, you're going to get slightly less coming out of it. That is the laws of physics. And as batteries have advanced, and especially lithium-ion has advanced, they've gotten better. So it used to be that if you put 100 megawatt hours into a battery, maybe you'd get 80 megawatt hours back. And you can measure this at various levels. You can measure at the cell level, at the enclosure level, all the way up to the high voltage level. And so as technology has progressed, this measure, which is called round trip efficiency, is a really key one, because obviously you don't want to lose energy. Energy costs money. And so you need to reduce those losses to maximize the revenue and ultimately the profit of a battery system. And so lithium ion right now at the high voltage level. So if we measure right at the transmission line where it's going in, goes through all the different steps between the transformers, the inverters, the batteries themselves, and then all the way back out. We're seeing the best systems are getting up to 90% efficiency, or maybe high 80s or right up to 90. It's pretty impressive when you think about all the different components it has to go through. And if you put 100 megawatt hours in, you get 90 megawatt hours out. Still costs you something, but that has been one of the big drivers to make these systems profitable.
Swetha, you mentioned density. What's the average density you've seen now being packed into these containers? By and large, the storage products are being put in 20 and 40 foot shipping container sizes. How have you seen that evolve?
That's a great question. I was honestly shocked at RE Plus last year in 2023, how many announcements there were. There were around the 5 megawatt hours in a container, and everybody's in that race. So I think in the next 2 years, if not right now, like safely by 2026, 5 megawatt hour per 20-foot container would be the norm, and there already is upward pressure on that to go up to maybe 7 megawatt hour. I think there is probably an upper threshold just in terms of physics and also like how much you can gain from that, but it's been a very exciting trend for us just to keep tabs on who's the next biggest containerized system. That's for sure.
And of course, Drew, the question on everyone's mind is the cost curve. Are we seeing in batteries the kind of cost curve we've seen and cost curve reduction that we've seen in solar PV modules and other technology in the industry? What would you have to wet our palate with?
It's very similar to what's happened in solar, thankfully, that the costs have come down, in some cases even faster than the more aggressive predictions. Even looking back 5 or 6 years ago, when we were up at, say, $200 a kilowatt hour at the cell level, that's come down. We've broken the $100 kilowatt hour at the cell level. And I should highlight, too, that it's not just the batteries. The system costs as a whole have gotten better and better and better. We used to be up, above $400 a kilowatt hour. Now that's coming down below $300, down to $250 a kilowatt hour. We expect that to continue to fall as systems get bigger, the technology gets better, and we just get more experience on financing these systems, building them, and operating them.
Yeah, I remember it might have been a decade ago now, Tesla and Musk saying that they would get below the $400 a megawatt hour or kilowatt hour range, and that would be the tipping point. And obviously, megapacks have far exceeded that and leading the charge in total system cost. I guess the question that's on my mind is, you showed the graphic of cell supply and the geodiversity of cell supply. We know there's a big push through the IRA for domestic content. Do you anticipate that we're going to see, where China was at one point 10x the size of the US in terms of manufacturing and supply, a shift to more local supply? And what do you anticipate that delta to look like and its impact on the sort of the bottom bracket that we could expect on battery pricing?
Yeah, there's certainly a big push for, using domestic content. Developers will definitely favor that. There is the 45x clause as part of the IRA. That's an incentive for the manufacturer, and they can ideally pass on that $35 incentive as a cost reduction in the end cost, which will at some point put them on par with like a Chinese made or Korean made cell. I think we're not going to be at that point for a few years. There is a lot of announcements and a lot of activity around domestic manufacturing. We're seeing a ton of announcements, but there's obviously going to be a ramp up for those, especially at the scales of these gigafactories we're talking about. There's usually a ramp up period for like the production to get up to the full capacity and really compete with like the really mature shops out of China that are already at like 98% production output. So it's going to be an interesting dynamic. I think for a while it could be, just kind of touting that domestic content as an advantage for the project and the product, and maybe offering a competitive price just to kind of get those orders rolling. But I think it will be a good 5-6 years when we reach that steady state to truly see what the difference is in terms of just the production cost of making a US made product versus something outside the US.
Well, it'll be interesting to see who the winners are. It has always been the nature of this industry that the folks you think are going to be winning maybe even aren't in the race in 3 to 5 years, sadly. You do a fantastic job of covering what you refer to as the usual suspects. There's even an entire several sections, I think, around page 119 that covers the different players that are currently in the industry. Drew, as we wrap, how do you think about the, kind of who's in and who's out, and who developers should be, looking to or concerned about? I feel like in the back of every developer's mind is, can I trust the manufacturer that I'm going to choose?
First of all, we received no compensation whatsoever from any manufacturer or supplier when writing this book. We really tried our best to make it agnostic to any one supplier or other. That said, we want whoever is reading the book to make sure they know who the players are, because there are a lot of big players, there are incumbents, there are new entrants, there are a number of different people in every aspect of the industry. And so including this usual suspects section, from everything from finance to sales to EPCs, we tried to list off some of the biggest players in each of those segments. So the reader will have an idea of who they are. Just high level figures. We just include a couple about, whether they're doing 50 gigawatt hours a year of cell, or whether they've just, gotten out of the lab phase. And so whoever reads it will kind of know who these names are, be able to recognize them when they get out into the industry.
Yeah. And for context, Drew is referring to at the end of every chapter. So for example, in the EPC chapter, 8.8 usual suspects goes through a list of turnkey and balance of plant contractors as examples of folks that you'd want to know if you are trying to identify key EPCs. At least they can serve as benchmarks. Well, benchmarks abound in the book that I have come to reference as not just the BESS book, but the masterclass on battery energy storage systems, thanks to Drew Lebowitz, Swetha Sundaram, and Sean Daly. This book can now be in your hands. I again reiterate that I think it should be on the desk of every engineering group in the industry. I think that you as a CEO or a leader should be investing, and I get no money unless you use our Amazon link. I get no money for saying this. I just really believe in the work that these three have invested in, so that we all can have a document that is a guiding principle around how this works. Guys, I think I've shared this to you offline, Drew. Like, the number of times folks reach out to me and they say, is there a course for how to get into the solar industry? Is there a course on how to do development? Is there a course on batteries? And so I'm grateful that you guys have written this book. We'll, of course, link to how to get the book in the description and everywhere else that we post about this episode. I would also be remiss if I didn't say, if you go to mysuncast.com/heatspring, you can get access to a ton of other courses and training that will help you along your own learning curve, thanks to those who have already clicked on that link. Yes, that does help to support us here at Suncast. And hint, there may be a BESS book course coming in the near future. So don't want to foreshadow something that can't come to reality, but I'm begging Drew and Swetha to join forces and put a course together on this book. I think it'll happen. What do you think, Drew?
I think we can make it happen. I wanted to point out too, it's also available as an ebook for those who want to read it on a Kindle or whatever device you have.
Yeah, and at the present time of recording, book is $40 for the print, $30 for the ebook. Please support these independent publishers, these independent authors. We will link to the BESS Book page, which is on the PowerSwitch website. We'll also link to the Amazon page. Deep congratulations and respect, gratitude for the work that the three of you are doing. Thanks for taking the time to join us here on Suncast and make us all smarter.
Thank you, Nico.
Thank you so much for your support.
And again, if you've made it all the way to the end, I honor you all the way to the end of the episode, watcher, listener. I so identify with you as an infinite learner, someone who wants to get the juice out of every single ounce that you can. Promise you, this is not only practically the only book that's been written, but it's definitely the best book that's been written on how batteries work. If you're not watching on YouTube and you're listening in the podcast, I've been holding it up and referencing it throughout the episode, so I apologize for that. You should go over and check out our YouTube channel, subscribe there. Thank you for joining us. Thank you to our sponsors as well who made this possible so that we can support this channel and just ask you to pay the thing that it costs you the most. That's your attention, your time. I really genuinely appreciate it. If you're getting value out of this and you want to share Suncast with others, you can easily do so by rating and reviewing the podcast. You can do that at ratethispodcast.com/Suncast. It takes just a couple of minutes, but it means the world to us because other smart folks just like you who want to level up find us through those mechanisms on the various platforms like Spotify and Apple Podcasts and even, yes, YouTube. Leave us a comment. Let us know that you liked it. Share Drew and Swetha and Sean's story with others and just generally help our community grow. Thank you for being here. Remember, you are what you listen to. Thanks again for showing up, Solo Warrior. It's half the battle.